Hey there, science fans. Today we're diving into the world of encoders, what they are, how they function, common faults, and how to troubleshoot them. So let's get started. These nifty devices are like the detectives of the machinery world. They tell us all about the motion and position of rotating objects. Imagine a spinning wheel on a robot. Is it going fast or slow, clockwise or counterclockwise? An encoder knows. It translates that motion into electrical signals, kind of like a secret code. These signals are then read by other parts of the system, like a motor controller. This information is crucial for things like speed control, position tracking, and precise movements. From robots to industrial machinery, encoders are everywhere. They help things move smoothly and accurately. Pretty cool, right? Now let's peek under the hood and see how these motion detectives do their thing. At the heart of an encoder, you'll find a rotating disc. This disc isn't just any ordinary disc, though. It has a special pattern on it, like slots or markings. As the disc spins, a light source shines through these slots. On the other side, a sensor picks up the light passing through. Each time a slot passes by, the sensor generates a pulse of electricity. These pulses are the encoder's secret code. By counting these pulses, we can figure out how far the disc has turned and in which direction. Clever, huh? Just like detectives specialize in different cases, there are different types of encoders for different jobs. The two most common types are incremental and absolute encoders. Incremental encoders are like keeping track of your steps. They tell you how far you've moved from a starting point. They're simple and widely used for measuring speed and relative position. Absolute encoders are like having a map with your exact location marked. They give you the absolute position of the shaft, even after a power outage. They use a more complex code on the disk, with each position having a unique pattern. So, depending on the application, you can choose the encoder that fits the bill. Section 4. Troubleshooting one-on-one. Common encoder errors. Even the best detectives face challenges, and encoders are no exception. Let's look at some common issues that can trip them up. Signal noise. Remember those electrical pulses? Sometimes they get distorted, like a bad phone connection. This can mess up the readings. Misalignment. If the encoder isn't aligned properly with the shaft, it won't read the disc accurately. It's like trying to read a blurry book. Wiring issues. Loose connections or damaged wires can interrupt those crucial signals, leading to faulty readings. Mechanical wear. Over time, parts can wear out, causing the disc to wobble or the sensor to malfunction. Don't worry though, most of these problems can be fixed with a little troubleshooting. Section 5. Fixing encoder issues back on track. Facing an encoder issue? Don't panic. Here are some troubleshooting steps to get things back on track. Check the wiring. Ensure all connections are secure and free of damage. A loose wire can cause major headaches. Look for any loose connections, damaged cables, or poor connections at the terminals. Tighten or replace any faulty wiring to ensure a stable signal. Verify alignment. Make sure the encoder is properly aligned with the shaft or linear guide. Even a small misalignment can throw things off. Inspect the signal. Use an oscilloscope to check the quality of the encoder signals. Look for any noise or distortion that could be causing problems. Look for any excessive noise or irregularities in the signal that might suggest electrical interference or an issue with the sensor. A stable, consistent signal is critical for accurate feedback. Clean or replace. If you suspect mechanical wear, try cleaning the encoder disc and sensor. If that doesn't work, you might need to replace the encoder. Remember, safety first. Always disconnect the power before working on any electrical components. Section 6. Keeping your encoders happy. Maintenance tips. Just like a well-maintained car runs smoothly, regular maintenance can keep your encoders in tip-top shape. Here are a few tips. Keep it clean. Dust and debris can interfere with the encoder's operation. Regularly clean the encoder and surrounding area. Check for wear. Inspect the encoder disc and sensor for any signs of wear and tear. Replace worn-out parts promptly. Proper lubrication. Use the recommended lubricant on moving parts to reduce friction and wear. Gentle handling. Handle encoders with care. Dropping or mishandling them can cause damage. By following these tips and troubleshooting any issues promptly, you can ensure your encoders keep those machines moving smoothly. Section 7. Battling electromagnetic interference, EMI. In this chapter, we will explore electromagnetic interference, EMI, and its impact on encoder accuracy and repeatability. EMI can cause significant disruptions in the performance of encoders, leading to errors and inconsistencies. Pause to S. EMI sources can be found everywhere, from industrial machinery and power lines to everyday electronic devices. These electromagnetic fields can interfere with the signals transmitted by encoders, causing them to produce inaccurate readings or even fail altogether. Pause to S. So, how do we counteract this invisible enemy? Here are some best practices to mitigate EMI impact. Shielding. Use shielded cables and housings to protect the encoder from external electromagnetic fields. Grounding. Ensure proper grounding of the encoder and its associated equipment to minimize electrical noise. Distance. Keep encoders and their cables away from high-power equipment and other sources of EMI. Filtering. Employ filters to block unwanted frequencies from affecting the encoder signals. Pause to S. By understanding and addressing EMI, you can maintain the precision and reliability of your encoders, ensuring they perform at their best even in challenging environments. Welcome to Chapter 8, Choosing the Right Encoder. In this chapter, we will explore the different types of encoders and how they work. Encoders are devices that convert information from one format to another. There are several types of encoders, including rotary encoders, linear encoders, and optical encoders. Each type has its own unique method of operation and application. Rotary encoders, for example, are used to measure the rotation of a shaft. They are essential in applications such as robotics, industrial machinery, and even in your car's steering system. Linear encoders, on the other hand, measure the position of a linear object. These are commonly found in CNC machines, elevators, and other precision positioning systems. Optical encoders use light to detect position changes. They are highly accurate and are often used in laboratory equipment and other high-precision applications. Understanding the differences between these types of encoders can help you choose the right one for your specific needs. By selecting the appropriate encoder for your application, you can ensure optimal performance and reliability. Remember, the right encoder can make all the difference in your project's success. Welcome to Chapter 9, Troubleshooting Encoder Issues in Real-World Applications. Here we dive into the practical challenges you might face with encoders, specifically focusing on how encoder issues can lead to miscounts or double counts when dropping individual boxes of pizza into a case. Imagine a high-speed pizza packaging line. Each box of pizza needs to be accurately counted and placed into a case. However, various factors such as signal interference, mechanical faults, or software glitches can disrupt this process, leading to miscounts or double counts. Signal interference, for instance, could arise from nearby electronic devices or power lines, affecting the accuracy of your encoder's readings. Mechanical faults might include wear and tear on the encoder or misalignment of its components, leading to incorrect position detection. Software glitches could result from bugs in the counting algorithm or improper integration with other systems. To troubleshoot these issues, start by checking for any potential sources of electromagnetic interference and ensure your encoder is properly shielded. Regularly inspect the mechanical components for any signs of wear and tear and ensure they are correctly aligned. Lastly, keep your software updated and perform routine checks to ensure it is functioning as intended. By addressing these common problems, you can prevent errors and ensure accurate counts in your packaging process. Remember, a well-maintained encoder system is crucial for the smooth operation of your application. Thank you for joining us on this extended journey through the world of encoders. We hope this additional insight helps you tackle real-world challenges more effectively. Keep exploring, keep learning, and stay curious. Until next time, goodbye.